Hey guys, welcome back to my YouTube channel. This is Ashok. Today I'm very excited to share with you the 20 essential technical terms that will act or that will serve as a fantastic resource for someone looking to make their transition into generative AI or start their career into generative AI. So by the end of this video, you'll be having a solid understanding of these topics, and then you will be knowing that which topic to delve into further. Without wasting much time, let's dive in. So guys, let's understand. So first topic which we are going to discuss is on Gen AI or the generative AI itself, right? So guys, I've created a separate video on this generative AI where I've discussed about the what is generative AI and what is the difference between a discriminative and generative AI and some of the use cases or the applications related to generative AI, right? So if you have not watched that video, so I'll provide the link in the iCard or the I button top here. So you can go ahead and watch that first. So basically, we have two different terms in generative AI to understand. One is the large image models and the large language models. So this generative AI basically is used to create new content or generate a new content altogether, right? So we basically what we'll dig deeper into this generative AI in the coming videos. But let's understand what is this difference, right? So what it can have image models or it can have a language models, and basically this language models is depending on purely on the text data. So the second term we'll discuss about this large language models. So guys, in this large language models, you typically understand what is large language model, building blocks of the large language models, different use cases will understand about the large language models, right? So we have many use cases which can be solved using this LLMs. And then we will see what is pre-training, how do you build the LLMs and how do you fine tune these LLMs, right? So fine tuning is very important topic in LLMs. And then we understand the different frameworks which are used specifically for large language models. So next we'll understand about the GANs. The third topic is on the GAN, so which is nothing but generative adversarial networks. So this GAN is basically a generative model, right? It's kind of a generative model basically which works on the two different neural networks, right? One is on the generator and the other is the discriminator. So this generator basically creates or generates a new data, and this discriminator will find the difference between the real data and your generated data. So the fourth point which we need to discuss is on the transformer architecture. And this is very much important topic, guys. So next video, next coming videos, I'll be discussing about this transformer architecture in depth. So if you are solving any kind of NLP use cases, natural language processing use cases using these LLM models, right? The backbone or the behind the scene, the architecture which runs is this transformer architecture, right? So we'll understand this into a separate video. I need to have a separate video for this, and I'll explain about what is a transformer architecture. So the point number 5, basically we'll understand about the attention mechanism. So there is a research paper called Attention is All You Need. So this, based on this research paper, right, this attention mechanism is evolved. Suppose you are solving the NLP or natural language processing use case, right? In you suppose that you have a sequence of data, right? And that in that sequence of data, that there might be some part which is very much important, and you need to focus more on it, right? And then you need to pay more attention to that particular sequence of data. In that case, you can use this attention mechanism. So next, point number 6, we'll understand about something called as tokenization and embeddings. So these two techniques are very much important, right? So if you have a text data, right, in NLP basically, so you have a text data and you need to provide or you need to convert that text data into some kind of tokens or embeddings or some kind of binary format, right, where or numerical formats where your machines can understand, right? In that case, it's tokenization and embeddings will be used. And the point number 7 is NLP itself, which is nothing but natural language processing. In this, right, this natural language processing is very vast topic, and then we have to understand about tokenization, stemming, lemmatization, stop word removal, part of speech tagging, name identity recognition, and we need to understand few of the libraries specifically for NLP, like we have GenSim, Spacey, NLTK, Stanford NLP, TextBlob, right? So we'll understand this when you are having an NLP series. Point number 8 is we'll understand something about the tree training. So this pre-training models, right? There are pre-training models already available. These LLM pre-trained models. So we need to understand about the pre-trained models. So if suppose you have a huge amount of corpus text data, right, and then you need to train your model on top of it, or you need to find some kind of patterns or insights from that particular text data, right? And in those cases, you will be using this LLM, large language models, and we'll see how we are going to pre-train. Basically, you need to have a huge computation resources. You will be taking a huge amount of time to actually pre-train these LLM models. So next we'll understand about the fine tuning. So again, fine tuning these LLM models. So the basic difference between a pre-training and fine tuning is pre-training you'll be having a huge amount of corpus data, right? You might be training with a lot of GPUs, you'll be using a lot of computation resources you'll be using, right? And in that case, these pre-trained models will be very big and very generic one, right? And if suppose you have your own data, or you have own label data, or you have own custom data, right? In that case, you need to make use of this fine-tuning technique to build your model on top of your own custom data, right? So that you can perform your tasks. Pre-training will be a generic one, and then fine-tuning is according to your task, according to your needs. So next we'll understand something about the prompt engineering. So this prompt engineering, right? So this is very much important topic, and we need to have dedicate a separate series for this prompt engineering, right? Because if you see the lot of companies nowadays, right, there is a separate role. They have defined a separate role as a prompt engineer, or separate designation for as a prompt engineering, right? So lot of companies are focusing, and a lot of companies are hiring these prompt engineers. So this prompt engineering is how you're crafting your instructions, right, and how you're crafting your prompts efficiently and passing it on to the large language models. So based on that, your instructions and the prompts, the large language model will give you a proper response. So point number 11 is on the GPT, which is nothing but generative pre-trained transformer. So you see this transformer word. So this is basically, we'll understand in the when you will discuss about the transformer architecture, right? So this GPT is also based on the transformer architecture. So this GPT is a family of large language models, typically built by OpenAI. OpenAI is again a research company, right? So basically they are known for their text generation capabilities. Like few examples of your GPT, right? So you can see GPT-3, GPT-4, and GPT-J. And this chat GPT, right? So you can see this chat GPT. So this chat GPT is built on top of this GPT architecture itself. Next, point number 12 is BERT. So this BERT is nothing but bidirectional encoder representation from transformers, right? So you'll understand, you will get a clear picture of BERT when you are discussing about the transformer architecture. BERT is also a kind of a pre-trained LLM model, right, which is typically developed by Google AI. So BERT is very expert if you are solving a use cases, right, on question answer applications and sentiment analysis. And the next point number 13, foundational models. So this foundation model is also a part of our family of these large language models, right? And these foundation models typically use this massive amount of text data in the code, and then it will try to find out some kind of insights or patterns in the data set. And these foundation models will be used to solve many use cases, right? So few of the use cases which it can solve is on the chatbots, virtual assistants, machine translation. So point number 14 and 15, we'll discuss something on LangChain and Llama Index. So if you are solving any large language model use cases, right, you're building your large language models, you need some frameworks or some tools to develop your large language models, right? In that case, these two, LangChain and Llama Index, will act as the tools or the frameworks which is required to solve these LLM use cases. In the coming videos, you'll understand the basic difference between the LangChain and the Llama Index, and we'll understand their focus, their purpose, their complexity, their use cases, and their strengths and weaknesses. So the next point, point number 16, is we'll understand something about Streamlit. Streamlit is kind of a framework typically which is used to build the web applications, right? If you are going to build web applications, and this Streamlit can be used. And also Streamlit is very easy to understand, easy to learn, right? And if you have any NLP kind of use cases, if you want to build any NLP applications, right, then straight away you can go ahead and use this Streamlit, and it will provide you some of the tools or some of the configurations, right, you need to set, and based on that you can build your web applications. So point number 17 is very important: Hugging Face. So this Hugging Face is basically a company which develops different tools or different libraries, or different, it provides different resources, right? So if you see this website of Hugging Face, right, you will get a lot of information and a lot of resources in this website. So typically if you are using any pre-trained models or the transformer models, apart from the models you will get data set also. And then if you are training, if you are fine tuning your own models, right, you are based on your custom data set, right, in that case you can download these pre-trained models or transformer models from the Hugging Face website, and then you can explore or you can build your LLM models. So point number 18 is vector databases. Typically if you see the traditional RDBMS, right, where you have a structured data, and then data will be stored in kind of tables, columns, rows and all, right, that is structured data that will be stored in tabular format. But if suppose you are solving an NLP kind of use cases or a text data, right, and that text data is a high dimensional data, right, in that case you need to convert that text data into some kind of format where you need to store that into some database, right? The text data will be converted into some numerical format, which is nothing but vectors, and these vectors needs to be stored in some database, and that is where this vector database comes into picture, where you are storing the high dimensional data in the form of vectors. So there are different vector databases, right? We have Pinecone, we have Fias, which is Facebook AI similarity search, and you have AstraDB. In the coming videos, you'll understand about the key concept of vector database, why we are using vector databases, and the different use cases on vector databases, and different vector databases like Pinecone, Files, and AstraDB, right? And we'll understand how to choose the best vector database. So next is a very important topic: LLM evaluation. So how do you evaluate your LLM models? How do you measure the credibility of your LLM models, right? In typically, if you see the machine learning and deep learning, you have classification and you have clustering. How do you evaluate clustering models? Like we have something called as precision recall, F1 score, ROC curve in classification, and in regression you use something called as a mean squared error, root mean squared error, adjusted R square values, right? And then typically in clustering you use something called as cohesion, separation, Silhouette coefficient, Rand index, Jaccard coefficient. Similarly, we'll see how do you evaluate your LLM models. So we need to understand two things in case of LLM evaluation, right? So you need to have intrinsic evaluation and extrinsic evaluation. Few of the methods we'll understand. One is the blue score. We'll use perplexity. We'll understand MMLU. We'll understand truthful QA. We'll understand Helm. It's nothing but holistic evaluation of language models. Apart from that, we'll understand chatbot arena. So there is something called as LLM leaderboard. In that, they will mention the which model is performing best, right? So those evaluation metrics also will be given in the LLM leaderboard. So we'll understand that as well. So guys, last point number 20, we'll discuss something about ChatGPT versus Gemini versus Claude. So this ChatGPT is from OpenAI, Gemini is from Google, Claude is from Anthropic. So the famous versions of ChatGPT is ChatGPT 3.5 and ChatGPT 4. And the Gemini is same as Gemini version 1 and the Gemini Advanced. Coming back to Anthropic, you have Claude 1, Claude 2, Claude, or you can call it as Claude, you can call it as Claude, right? Whatever you like. So this Claude 3 also has 3 different versions. One is Haiku, Sonnet, and Opus. This ChatGPT 3.5 is a free version. You can use it without any subscriptions, but ChatGPT is a paid version, so you need to have a subscription to use this ChatGPT 4. Similarly, Google Gemini is a free version, and Google Advanced is a paid version. So similarly, Claude 3, in this Claude 3, right, you have this free version, which is Haiku, and these two are the paid versions. So you need to have a subscription to use this Sonnet and Opus, but you can use this Haiku freely. I'm planning to make a video on this ChatGPT, Gemini, and Claude. We'll see the basic difference between the three and also how to use them. So guys, this is the 20 essential technical terms which you need to understand to build any kind of generative AI, to understand generative AI and build any kind of large language models. So guys, there is a small task for you guys for today. I will write few points, few terms here, and I want you to explore those points and then provide me the full form of those in the comment section. So first is PEFT, LoRa, QLoRa, SFT, RAG, RLHF, PPO, and DPO. So explore this, guys, and provide the full form of all these points in the comment section. Okay guys, that's it from my side for this particular video. So today in this video we have discussed about 20 technical terms in the world of generative AI, right? And then in the next coming videos or in the coming videos, what I'll do, I'll dig deeper into each one of these points, each one of these topics, right? And we'll create one video for each topic. I'll meet you all in the next video. Thanks for watching. If you really like this video, hit a thumbs up, and please subscribe this channel and share with your friends and share with those people who are going to make the transition into generative AI. Meet you all in the next video. Till then, take care, keep learning, and keep rocking.